morning, Stats fans. How we doing on this fine, sunny Tuesday morning? A little chilly outside, so if you go outside, it's not shorts and t-shirt type of weather. You may want to put a coat on and a sweatshirt on. It's a little chilly out there, but it's sunny outside, which is nice. Dries some things out. It's going to be a little chilly the rest of the week, the weatherman says, but at least it's sunny outside right now, which is good. And it's not like yesterday where all my hair blew off my head. Beautiful day outside. I hope everything's going well within your family and everything's going well and you're staying ill-free. Once again, keep your social distancing. Quicker we can get through this, quicker we can get back to normal. I miss you guys. I wish you were sitting in this classroom today and I was teaching you today, but it's our reality. So please do continue to do your social distancing. They say it's making a difference. Also, a little funny note about yesterday. When I download my YouTube videos, it has to go through a filtering process. The stats one took a little bit longer yesterday, and the reason why I think is because I had, we started out the lesson with our political, with the Trump and Biden election thing, and when all of a sudden a few keywords get kicked into the YouTube, the filtering process takes a little bit longer to be able to get through all that material because they want to make sure it's not a political ad for one candidate or another, because they don't want to have the political ideas going there, and because these are all videos for kids. So it's interesting how the YouTube's people, the big brother of YouTube, took a little bit longer to filter out my my Biden and Trump thing yesterday. So it'll probably take longer today because I said their words. Yesterday we talked about confidence interval. We'll start out with a confidence interval problem here today just to review the idea. Once again, what we want to do with a confidence interval is we want to use our sample mean to get two boundary values for our population, because once again, to survey the entire population is tough to be able to do. But if we could just get a sample, and if the sample's large enough, we can predict out with respect to some confidence where our population mean's going to be. And that's what we want to be able to do, is calculate our population mean. To find our confidence interval, and once again, you do not have to memorize these. Tomorrow when we go to the next level of our confidence interval, you'll be given a T-chart, and on that T-chart you'll be able to find these values on the T-chart. But for right now, I'll give them to you. The confidence interval is calculated by our sample mean, our Z for the confidence interval, standard deviation divided by square root of n. Now, this also can be the sample standard deviation too. So it does not have to be the population standard deviation. Whatever standard deviation we can come up, we'll take it, we'll use it. Whatever we can get. The Z for the confidence intervals, if we have 90% confidence interval, this is 1.65, 95% confidence interval 1.96, and 99% confidence interval 2.58. The mean height of 40 men was 177 centimeters, which is about 5'8", and a standard deviation of 20 centimeters. What would be the confidence interval for the mean population? Okay, what would be the confidence interval for the mean for the population of the men? Well, if we take a look at what we have here, we have a mean height of 40 men. So our sample size is a value of 40. Their mean was 177 centimeters, and their standard deviation is a value of 20. What we want to do is calculate a confidence interval for these values here. So what we have is, we have to take a look at 90% confidence interval. We have to use a Z value of 1.65. So we have two values or two little equations that we have to calculate. We have X bar plus our Z value, standard deviation divided by square root of n. So we have our X bar, which is 177, minus, this is plus or minus here, our Z value 1.65 times the standard deviation, which is 20, divided by the square root of n, we have the square root of 40. So we can clickety-clack that through the calculator. 177 minus 1.65 times 20 divided by square root of 40. And we get 171.78 centimeters. Then we find an upper bound by doing the exact same thing, but now we're going to add. So we have the 177 plus 1.65 times our standard deviation of 20 divided by square root of 40. So we do a plus and we do a minus action in regards to calculating two different values. And once again, these are boundary values. So I can go back to my calculator. If I want to use my second entry and just change my minus sign to a plus sign, it gives me 182.22 centimeters. What this tells me, and now when we're dealing with this, we have to give a final statement in regards to our confidence level. We are 90% confident the population mean height of men is between 171.8 centimeters and 182.2 centimeters. And you have to give me a final statement here to go with this. Okay, you just can't give me two values and say I'm done. You need to give me a final statement. I'm 90% confident the population mean for the height of men is between 171 and 182 centimeters. Okay, you need to give a final statement. We go to the 95% confidence interval. This one I want you to do on your own, but once again, just wait. I want you to do this problem on your own and work the problem out. So you're going to want to hit pause on your YouTube video again. Hit your pause, work the problem, and then turn back on and check your answers to your problem. So we still have the same values. Our Z value for 95% is 1.96. So we do the exact same calculations. 177 minus 190.96 times 20 divided by square root of 40, and 177 plus 1.96 times 20 divided by square root of 40. So I'm going to clickety-clack through my calculator. 177 minus 1.96 times 20 divided by square root of 40. I get 170.8 centimeters. And change it to a plus. I get 183.2 centimeters. And once again, don't just leave me with these values. Give me a final answer. 90, and these answers are going to be pretty much the same every time, except for you're going to have to change what you're talking about. We have 95% confident. The population mean for height of men is between 170.8 centimeters and 183.2 centimeters. Now, to be more confident, what had to happen here? Well, I went from 171 as my bottom 0.8 to 170.8. Here I went from 182.2 to 183.2. So to be more confident, that range of values has to be a little bit bigger. okay, because I'm going to be a little bit more confident, so I need to make sure I cover 95% of the values. So this is our confidence interval, and we'll be doing this type of process over and over and over again. To go to the last page of our notes yesterday, our maximum error. Our maximum error is the difference between the population mean and the maximum distance to our confidence interval. How we find our confidence interval is our x bar plus or minus our z for the confidence interval, standard deviation, square root of n. What we're talking about here is the difference here, which is this value here. If I look at my value here, here's my sample mean, which we're hoping is a population mean. But this distance that we go out in this direction and this direction, here's our x bar, is a z times our standard deviation divided by a square root of n. So I'm either adding this value or subtracting this value, and what we are saying is that we hope the population mean is going to be somewhere between those values here. So this distance further out to this way and this way is that maximum error. And we'll utilize that idea here. If the population standard deviation, once again, is not used, the sample standard deviation can be used. So if the population standard deviation, you don't know it, use the sample standard deviation. That's okay. That's okay to use that. We just want a value. So what happens here, I'm going to put CI in there, is we have x bars, z for the standard deviation, or z for the confidence interval, standard deviation divided by square root of n. So this sort of just changes to a sample standard deviation rather than a population. That's okay. We can use that, just so we have a value there. If you want to be more confident the population mean lies within an interval, you must be willing to trade off a bigger confidence interval. This will widen. Once again, just because we are multiplying, this value here becomes bigger. Is 5 a 95% or 99% confidence interval? This is 2.58 that I'm multiplying by. It's 1.65, it's only 90% confidence interval. So because I'm multiplying by a smaller number, these numbers that I'm adding and subtracting are going to get smaller. To be able to find confidence intervals, sample size must be large enough. We use above 30. You hope that 30 is going to be large enough to be able to determine this confidence interval. We'll talk about tomorrow what happens when they're smaller than 30. But when you're above 30, this is going to be use a z value. We want to use a z value. Okay, to find this maximum, that E be the maximum error. Suppose you have a maximum error. You have a maximum error, and you want to be able to determine out what sample size can I have to be able to get this maximum error. Put a square there. The minimum sample size for a maximum error can be calculated by z for the confidence interval, standard deviation divided by the error, and that's all squared. And where this comes from is this error is calculated by this value right here. This is your error. So this error is equal to the z times sigma divided by square root of n. What we're saying in this type of problem when we're trying to find what is the minimum sample size, I can multiply both sides by square root of n. So we have square root of n times e is equal to z times our standard deviation. We can divide by e, So square root of n is equal to z times sigma divided by e. Then to get rid of my square root, I have to square. And that gives me this right here. Okay, so this gives us a way of calculating a sample size. Given a sample size, what does our minimum sample size have to be for an error that we have? We're willing to live with this type of error. So if I'm willing to live with this type of error, what type of sample size do I need to gain to be able to get this type of error? And once again, this is very similar to the problem that we did at the beginning, so I'm not going to go through it again. It is the exact same thing. The only one thing I will talk about is actuary fields. To be an actuary, you have to go through, it's called an applied math field when you go to college. But if you go to an actuary field, it's a very, 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 very well-paying job. Basically, it's a number cruncher for companies, for businesses. Everybody has to have actuaries. All the businesses that you have, all the big corporations have these actuaries. All the insurance companies have these actuaries. The reason why is because they want to be able to make predictions. They want people that can make predictions about certain lines of products. Is it going to give me a profit? Okay, because businesses go into business to make a profit. They're not in business to take a loss. So they need to be able to have people that make predictions out to make these profits that they want within the companies. And as you can see, as you work through the actuary fields, you top out $150,000, $250,000. You make really good money, and you start out really good money also. So if you're interested in mathematics and like the applied math field, there are jobs within every company, every corporation, every business, every bank, every insurance company, every type of investment companies have actuaries that sit there and predict out what will happen, and you being able to make profits within companies. Everybody will have them within their companies. So if you like mathematics, you don't like accounting, you don't like science and engineering, this is a way to be able to stay with mathematics and get a very well-paying job in the actuary fields. And they're called fellows. Yeah, they're fellows. I'm not going to go through this problem. It's very similar to the problem that we just did right here. What I want you to do, if you did not complete the worksheet that you did that I assigned yesterday, go ahead and complete that today. Go ahead and complete it for today. Tomorrow we'll get into what happens when the sample size is less than 30. Okay? So, just complete the worksheet that you had for yesterday, and that's all that you need to do for today. If you have any questions about anything, please do comment. Send me a comment. I will go over types of problems in class or on video tomorrow. So just make comments in regards to that, and we'll go forward with that. Stay safe. Stay away from the illness. Keep your social distancing. I miss you guys. I wish you were here. Let's get this back to normal as quickly as possible, but we also have to do our part in regards to that. Adios. Folks, have a great day.